again, good afternoon, and thanks for joining us today. We're excited to bring another BioTeam webinar to you. And today, just a bit of housekeeping. So as always, we have Q&A within the webinar. So if you have any questions for the speaker or for BioTeam, feel free to post your questions in the Q&A. I'll answer some directly in chat, and we'll also, at the end, go through some of the questions and have Simon himself answer them. And so, yeah, so today, again, we're excited to have this webinar from Dr. Simon Twigger. So Simon is a PhD in biochemistry from the University of Nottingham in the UK, and worked on ubiquitin and related proteins for his postdoc work at the Medical College of Wisconsin in Milwaukee. So Simon specializes in building software that's actually usable by scientists. He's formerly an assistant professor working in the areas of genomics and biotechnology. He joined BioTeam back in 2013, and since then, he's continued his focus on harnessing the cloud to build software tools for scientists, while also embracing the power of DevOps to create dynamic computing architectures for modern informatics. So again, if you have any questions, please post them to the Q&A. Also, the recording for this webinar will be sent probably next week. So if you registered, you'll automatically get a link to the recording to download and to share, as well as the slides. So thanks again, and Simon, take it away.
Thanks, everyone. Well, thanks very much for stopping by to listen today. So the title is Designing Scientific Systems for Change. I'll give you a little sort of intro as to what that covers and perhaps what it doesn't cover. But just to follow up on sort of what Adam was saying before, I thought I'd start with a little bit about me. Kind of as Adam alluded to, I spent a lot of the first 18 odd years in academia, going from sort of biochemistry, bioinformatics, genomics, genome databases, ontologies, semantic web related things, a bit of clinical informatics at the end. Got into cloud computing through some proteomics work we were doing back in the late 2009, 2010 area. And then not too long after that, joined BioTeam, and sort of work that we've been doing here, again, cloud computing, software development. So sort of in a chronological order. So, started with more sort of software and building things. And then, the other thing that BioTeam does are IT assessments. Then we moved into data commons. And now there's like these ILITs, interoperability, searchability, sustainability. So sort of more holistic system level properties of the things that we're building. And so that's kind of been my career to date. There's this little sort of green blob in the middle between the two, which I'll try and come back to a little bit later, because that sort of influenced some of the stuff I'll be talking about today. So we're talking about BioIT and the things that we do. And, this is sort of designing systems for change. Again, sort of a caveat up front. I'm not going to go into hardware, gory, sort of infrastructure-y stuff. This is far more on the people, making things work. How do we make things change side of things than it is on the gory, building things side of things. Again, sort of reflecting more of the ILITs side of stuff. So with that in mind, what are the sorts of things that we work on? So these are just some of the things you might have heard or might be going on in your environment. Storage isn't working. We want to go onto the cloud. We'd like to come off the cloud. We don't have enough compute. We want SaaS platforms. Data's too slow. All of these types of things are likely going on in your organization. And these are certainly things that we've come across on a painfully regular basis at BioTeam. And so, something always needs to change. But when you look at this, you go, okay, well, storage is an issue. How hard can that be? But that's the challenge. These things often are complicated. And so a little bit of a script here. I had some screenshots of other things, but I had to change that a little bit. So I went with a script version, which from a movie you may recognize, but, it kind of depicts a scene you may be familiar with. Harry, a bench scientist, sitting at his desk, staring at the download screen, and then the IT guy comes in, and Griffin, the IT guy, asked, why do you have so many USB drives back there? It's a data governance disaster recovery nightmare. Harry looks up and goes, it's complicated. And then Griffin asking sort of, Griffin, why is the lab internet so slow? I can barely do any science. And again, it's complicated. And that's kind of the sense I get from many of the things that we work with. On the face of it, it's quite straightforward. More storage, faster internet. But it's never quite that easy. Why is that? This is kind of an illustration taken from our website. So you can see, on the left-hand side, all these things coming together: scientific instruments, data sets, community data sets, lots of information coming in, going through the double helix in the middle there, or the infrastructure components. That's like the policy and governance side of things on the top there, ultimately being combined with workflows, analytics, and all these other fun things on the right-hand side to lead to scientific discovery. Those are the bits, the pieces that we focus on a lot. But the other component of this, is that they're all created, managed, deployed, and used by people. And that's often where, some of the excitement comes in, as we're probably all aware. So in terms of, working with people, I went to an acknowledged expert on these things these days, our AI overlord. And I asked ChatGPT to give us a quick summary of, working with people, and particularly why it's hard. Don't expect you to read the whole text, but it did a fairly reasonable job. But, the section in the middle here, aligning everyone's effort, achieving common objectives, and bringing together diverse people, diverse background with different goals. That's the challenge. And that, I think, is very much borne out by experience. I thought I would give the humans a fighting chance to sort of rebut this. So I asked it to tell us, why working with people is easy. It came up with, many of the challenging things, diversity. But then, kind of when it came together here with, common group, common goals, common values, motivations, aligning everyone and communicating effectively, this is what makes the magic happen. And so kind of to summarize, working with people, lots of differences, can be hard to communicate and find common ground. And we'll sort of see a number of those examples a little bit later. On the flip side, all of these things can be positives when you have common goals, work together, communicate effectively. And so, you've got all these bits and pieces. How do you figure it out? So that's the question. We've sort of got this situation, lots of complexity in the work that we do. There's technologies, there's people. Sometimes they work together effectively. More often than not, something needs to be fixed at varying levels. And it's usually not quite as simple as just deploying more storage or fixing the network, quote unquote. So how do you figure out, how to bring all these things together? The common goals, the common ground, understanding the complexities, figure out what's really happening. And then ultimately, how do you know what to change? You've got this complexity. Which bit do you need to fix? And is it the obvious thing, or is it something else? And that's kind of what we're going to be talking about today. So the way that we have started to work on this over a number of years to kind of address some of these first sections brings me to this first topic: design. And you are perhaps sitting there going, design, well, that's interesting. I don't know if I design things. I don't, I'm not building the next Aeron chair, or I'm not sort of, designing cool new clothes or other things that we typically think of as design. But perhaps this quote from Herbert Simon, Nobel Prize winner for economics in 1978, may resonate. Everyone designs who devises courses of action aimed at changing existing situations into desired ones. And I suspect that we all do this, whether we think of it explicitly as design or not, is perhaps the question. But a lot of what we try and do, and certainly at BioTeam, what we try and do, and I suspect what we all do in our various businesses, is try and, we're improving things, we're changing things, and how best to do that. And so when I've looked back at what we do at BioTeam and what I've done in the past in sort of BioIT and other places, what sort of design do we do? And there's a list down the side here, software design, information design, graphic design, organizational design. There's so much of what we do, which ultimately is design. And this is the screenshot on the right-hand side was sort of, I had someone mention to me a number of weeks ago that, they were talking about design, said, well, you don't do design. And I think sort of in their mind, they were thinking you don't make things pretty. But then when I look back at my Kindle selection, I'm going, certainly a lot of books on design that I've picked up over the years to help me do what we do. So all of this stuff, I think, is very relevant. And the nice thing about design is, it has a rich body of knowledge, very established tools that can help us understand what's going on and figure out all the bits and pieces that we need to make our BioIT things work more effectively. And I guess the other view that I have here is we're going to build these things anyway. We're going to have to do our job. We might as well, design things intentionally rather than accidentally. And we should leverage the tools that the design community has accumulated over the years to really help us do this. And so that's kind of what this first section of the presentation is going to be about, talking about some of those approaches that we use and how they can be deployed to figure out what's going on and provide solutions for us. So the nice thing about design is there are a number of sort of overarching methodologies, which I'm going to go through one here. It's called the double diamond, but you may find elements of this you do already. But the nice thing about this is it provides like an actual framework so you can know where you are. So it starts with an initial problem, which might be my storage is broken, whatever it is. And then it sort of has this initial phase of discovery, and those arrows sort of going up and out kind of convey the idea that at this point you're gathering information, you're broadening scope, trying to really figure out all the information you can about a situation. And then at some point you stop that and go, okay, we've got as much information as we want at this point. Now we're going to make a conscious effort to focus. And the goal here is to focus on what's the actual problem. Maybe someone came to you with storage, but perhaps the actual problem is, the network really isn't supporting data transfer, which is why they store it in some particular location. So ultimately, the goal of this first part of the diamond is to focus in on the actual problem. And then from there, kind of go broad again, developing solutions. What might work? What might be the solution to this? Again, brainstorming all the kind of cool things that happen here to get a range of options that you can then focus in on again, narrow down to a solution. So the nice thing about this particular approach is it tells you that, okay, we're in the discovery phase, we're going broad, but at some point you acknowledge you have to stop, and then you're trying to focus. And at that point, you're not off on brainstorming. You're really trying to narrow things down. It gives you and your team a focus on what's going on and when you should stop doing one thing and move on to the next. So with this as a general framework, here's the kind of things that happen at each of those stages. Again, on the discovery side of things, you might be doing interviews, reading, research, workshops. I'll show you some of these things more specifically in the following slides. Then in the defining phase, you've got a lot of information, so you're trying to distill it down. You synthesize things. You're creating maps of what's going on. You're trying to figure out where things, where an intervention point might be. And we'll talk specifically about these elements more today. And then on the other side of things, again, you have a better understanding of the problem, and perhaps now you're trying to figure out, okay, how can we fix it? And then ultimately you want to deliver a solution at the end of all of this. So those are broadly what happens at each of those sections. What I'm going to do now is sort of talk through, give some specific examples of the activities that we do at BioTeam, but also there are activities that you can do too. They're not, they're not rocket science. And again, they're fairly well developed design techniques that are well documented out there that you can apply too. So the first one is just the good old-fashioned interview, talking to people. Really shouldn't underestimate this. At BioTeam, we do a lot of interviews as part of our work, and they're very informative. They're usually a lot of fun, and they get a huge amount of information out of folks. I put a couple of thoughts here for when if you try this yourself. Clearly, we talk to people on a regular basis, but interviews are a little different. You're trying to make the best use of someone's time. So do your research, understand who they are, why they're important to you, and figure out what you want to ask. The other interesting observation that many of my colleagues and I have made is when we go into an organization, when we sit down and ask them about the thing that's not working or the thing that's going wrong, it's maybe the first time anyone has actually sat down and listened to them and paid attention. So quite often, they just start talking and you just sit back. Take good notes, record the discussion, and then review it afterwards to try and figure out what they're telling you. So interviews, again, it could be a formal interview, discussions, chats, however you want to do it. But talking to people, as we'll see a little bit later, is invaluable. The other types of things that you can do out of that is, this is an empathy map. It's a little busy. If you kind of sort of ignore the colored squares in the near term, the map is sort of divided into 6 different segments. So what you're trying to do here is, look at a particular type of person. In this case, it's the big data scientist PI and the cloud. That's the situation we're looking at. And so what you do is, based on your interviews, you can start to go, okay, for this generic type of person, what are they hearing? So on this left-hand side here, what are people telling them? What influences do they have? And they might be hearing things like the cloud isn't secure, or the cloud's as secure as it gets. So you start to understand the inputs they're getting on that side. You can understand and start putting notes on what are they thinking, what are they feeling. You can get that sense from the discussions you have with them. Everything from how are we going to pay for this? We have no support for the cloud, or this looks really complicated. So you get some idea of what they're thinking. So the whole goal here is to try and document and put down an understanding or representation of a particular type of person and what they're thinking and feeling, what their motivations are, what have they got to gain, over here in the bottom right, why do they care about the cloud? And then the pain, what's the problems? So it's starting to capture in one place a lot of information about some of your key constituents and the things they're trying to achieve. And so we find this to be very helpful, again, as a way to sort of document this and to refer back to later on. So empathy maps can be a very helpful approach. And then, often what we then do is sort of distill the conversations we have into specific use cases. So again, sort of capture in a sort of a pithy way the specific things that we're seeing. So this one is, someone, a staff researcher at an organization who would like to have support to use the cloud. So, in this bottom left-hand side, somewhat generic, as a PI, I want training and guidance in order to be able to effectively utilize the cloud to support my research. So you kind of sum up the use case like that. And then you can define the core motivations, the potential inputs, in this case, data sources, the cloud service providers that we know and love. So we can start to sort of, again, encapsulate use cases. And these, again, are very good communication devices to share with folks. They're a great output from this type of research so that people around the organization can understand what people are trying to do and why, and some of the inputs that are coming into them. So use cases, I think, have been very popular with the people that we've worked with as a way to share the results and share the understanding of what's going on in an organization. Another way to do that, this is a kind of focused on a particular task. I want to do this, and here's, what's going on for that. But a lot of what we do are processes. There are lots of steps. And so another way we can map that are journey maps. Again, another sort of popular design tool. The one on the right here, you can see is for a research data journey. So the scenario here is you're in a lab and you're generating data, you're managing your data, and ultimately going all the way through from gathering preliminary data, acquiring supporting data, generating new data, managing that data, analyzing it, publishing it, archiving it, and reusing it. So, how you would hope that the steps of data generation and data use might go on in a lab or an organization. And then you've got a number of ways of sort of visualizing the results. The emojis, which kind of convey how people are doing at a particular spot, and the sort of the qualitative sort of estimated sort of graph of experience. So in this particular instance, you can see that, the lab folks are generally fine at acquiring data, generating new data. They're doing, there's some issues around managing that raw data. And you can look down below here at some of the hardware involved. So maybe there are issues here with, the data is being put on a particular instrument, but getting that onto the main network is challenging. Maybe getting it to the primary storage is challenging. So there's some issues there, but they can study their data, they publish it, that's great. But archiving, again, it starts to go off the rails a bit here because maybe they don't have a great solution that it's on a USB drive sitting somewhere, who knows? And then, it all tends to go off the rails totally at the end in terms of reuse. And that can be for any number of reasons, technological, sociological, and so on. But again, the nice thing about this is it captures a flow, a process of importance to people, and it gives you ideas of where things aren't working, and potentially helps you communicate this process to others, but also gives you some places to start to try and fix things. We can take this, a lot further. So the next picture is a far more detailed, sort of in-depth journey map. This one was for, and again, I'll show you a zoomed in version of bits of it in a moment. So you won't be able to, I'm not expecting you to read this chunk, but this is looking at an organization. It was an academic organization, and this looks at a scientist coming in and how they interact from IT, all the way from before they join the organization to joining the organization, all the way through getting their lab set up, getting support, and then going on from there to learn how to use other tools. And it has sort of key elements like an empathy map again at the top, showing the high points and the low points. Talks about key phases that the scientists would go through. And then it goes into detail about physical touch points. Are they using a website? Are they using documentation? Who's involved? That's all these squares here in the gray and the purple. So again, quite granular as to all the pieces that are involved in this. And then, we kind of collect the positive and negative feedback we hear at each stage. So you can sort of do if you squint, you can start to see a bit of a bar chart, some more positive stuff here, but quite offset by the negatives. And generally, it's there are some issues, but that's often why we get called in. A slightly zoomed in version of this that you can see from the top left-hand corner. Again, trying to sort of combine, empathy and understanding the steps that someone's going through and why. So we've got the scientist mindset, when they are looking at joining an organization, they're looking at the IT and going, can this organization support my work? And then, they're trying to find out information. They're looking at the websites and so on. They're having phone calls. That's how they get information at that point. Then, once they get started, how do I get the basics of my lab set up, and so on and so forth. So again, you can sort of map out the various steps at quite high granular level to understand what's involved, who's involved, what's working, and then that will quite quickly highlight some of the places that aren't working or the things that are working that you can build on. So, we've talked about design methods, and, in this phase, they really help you collect and communicate information. We've talked about some of those here. But then as we move on to this, the next stage is, what's really going on? We've got information about people and processes. How can we extend that to address the rest of this process here? And this is where the systems component comes in. This is sort of, I first got introduced to this and that little green square in the timeline at the beginning, in between my academic career and joining BioTeam. I sort of segued into peace building and other sort of non-profit things for a little while. I got introduced to systems thinking at that point. And it's very relevant, I think, to what we do. In fact, you'll probably look at some of these things. This is the wonderful Boehringer, now Roche metabolic pathways poster, which may have sat on a lab near you on the wall. At least it did when I was growing up, as it were. That's an awesome system, proteins and enzymes and all interconnected. Or, from the bio-IT side, you might be more familiar with, things like the variant annotation pipeline diagram on the right-hand side there, where its data goes to storage, and then we pull it off GCP and we put it into compute. And we save results in different places. We have pub/sub messaging to sort of monitor things and provide feedback. Those are all systems. They have components, relationships, dependencies, feedback. But we're not talking about those today. Specifically, we're looking more at sort of things where people are in the mix here. And so here's an example of that. So this is a systems map, unlike the diagrams we saw before. This is sort of showing you how A leads to B, which leads to C. And this is what I euphemistically call the shadow IT arms race, which is a fairly simple system, which perhaps we can recognize. You can start at sort of any point in this circle, but maybe we start on the left here where, scientist goes, I just need to get some IT to get things done. So they use a convenient, unsanctioned, call it shadow IT. That's good for them, but unfortunately it causes increased IT risks, IT issues, security risks. So, the institutional IT, needless to say, reacts to that and institutes more security protocols. The downside of that is it makes using official systems harder. And so that leads to, people wanting to use more unsanctioned shadow IT because the burdens of using the existing systems are just getting worse. So you're kind of in this loop, and it's a sort of a negative feedback loop in this respect. And we see this a lot in organizations. So this is a very simple system, kind of again, sort of in that arms race sort of model, which you might be familiar with. Country A buys nuclear weapons, it alarms country B gets nuclear weapons too, which alarms country A, and around we go. So it's a very simple but sort of relatable system. But the nice thing about this diagram is it then says, okay, what happens if we break this loop? It gives us a place to figure out how to fix it. And so that's kind of the goal of all of this, is if we've got this, how can we interrupt it? So you can imagine here, if we educate and train to raise awareness of the risks of shadow IT, that might break it. Perhaps if IT was more selective with security changes, not like blanket, treat everything as if it's super hyper sort of protective data, maybe they're a bit more quality, selective about how they do that. We can improve the official IT systems so that they are easier to use, perhaps, than shadow IT. And if there are key use cases that people are trying to sort of solve themselves, maybe we solve them for them, and again provide official options that meet those needs. So the system gives you an idea of what's happening and why all these things are connected, and it gives you a way to perhaps identify intervention points and approaches that can stop the issues. So we've done similar things with other organizations. This is a large-scale organizational IT systems map. Clearly not meant to read this. I'll zoom in just a moment. But as you look at the colors, this kind of shows you what they, all the areas, if you will, that we found were playing into, the dysfunction at times of sort of the scientist IT relationship in this particular organization. And you can see it has a lot of different components. Everything from, communication, and we'll come back to that, but the way the scientists interact, physical locations, is IT accessible to the science, or is it off in some building somewhere else? Security and how that plays into the scientist's experience. It impacts hiring and the ability to, grow your institution. There's impacts, historical impacts, you guys always used to do this, and we still remember that. And so that colors our vision of how this organization works. Customer support, again, plays a big role. So by doing this type of systems mapping, you can start to see, again, the big picture areas that are playing a role. But in the heart of it, kind of referencing back to what we talked about before, is communication. So, as we touched on the way at the back of the beginning, we've got people. And so it can be hard to communicate, find common ground. And that's a lot of what we typically see when we're looking at sort of organizations and the people that work in them. So how do we do this? How do we get to common goals, working together, communicating effectively? So this is the zoomed in version of the core loop communication. Again, there's a variety of boxes here, but I'll give you a quick guided tour. The bold arrows sort of around the middle here are, again, the core loop. But maybe, and it doesn't show everything, but perhaps, we can sort of start here. Scientists, again, they have frustration with IT. They ignore IT. They seek alternative IC solutions. So this is kind of like the shadow IT approach. But when they do this, this generally leads to poor communication because they're not talking to IT, they're ignoring them. And, this doesn't bode well because all of that tends to, feed into all of these differences here. So scientists don't understand the implications of the IT that they're doing, or, the solutions that IT perhaps has because they're not working very well together. On the flip side, IT doesn't have a great idea of what the scientists doing, what their drivers are, and how they can help. So this, to be honest, is at the heart of many of the issues we see. All of this then sort of starts to spin out where IT doesn't really get what science is trying to do. They build things, but they miss the mark. Users have a bad experience. This then feeds back into frustration with IT, and around we go. You can then throw into that from that previous diagram, all the security issues. Again, security is an issue, as we all know, and it clearly is an important one, but there's a tendency perhaps to be over secure, which puts a whole bunch of burdens on people, which doesn't go well unless it's managed effectively. Same with support. Support that they get doesn't really meet the needs. People again, they have a bad experience. And on this side over here, isolated IT. Again, that can be both a physical and sort of a mental isolation of, how they relate to the science that they do or that their institution does. One of the things perhaps that struck many of us in the early days of our assessment is you could almost sort of predict how happy people were going to be in an organization based on how close they were to someone who could solve their IT problem, who actually got their problem. So, that person in your lab who's worked with you for years, who's your IT guy or gal, they're great because they understand it, they're there, they're available, they understand the problem. The more the IT person sort of gets, relocated to a central office, and you don't see them very often, or to a different floor behind a biometric barrier, or even to a different building or different part of the town, the further away they get, the less happy people are. And again, my opinion, what we've seen is communication just goes downhill as a result of that. So you've got this core loop. Again, we've got scientists coming in here. And so the nice thing about the system map is it helps us put all the information we gathered before sort of into context. So we did, we've got the use cases and other things that we collected before. Now we've started to define the problem. And, we're narrowing it down to elements, like communication as being a core element of what is not working in our organization. But we clearly know there are lots of other things feeding in that can sort of help with this. So, the question now becomes, we've got all this information, we know how it locates, how are we going to change it? Where should we sort of impact things? And one thing I should say, this particular system that we're going through here, it's sort of we were brought in to work and evaluate sort of IT and how it was working. I don't have a slide here anymore, but in conversations, IT and science, they often do things to aggravate each other. So even though this is more of an IT-centric view, both sides, against communication, so both sides have things to work on here. But change, that's our next goal here. So in the situations we've looked, at so far, we are trying to find these common goals and communication. We've certainly seen both from the individual interviews, the personas, we can see that, things aren't working as they should. So we can check that off. So the next question is, how do we get to here? How can we solve this? And so let's come back to, the system and the information we've collected. So now, based on, the empathy maps we have, the journey maps, the use cases, we have a lot of information that we can use to inform this top part. So, there really should be a lot of data here that can be used to show and communicate to IT and to the scientific community, here's what we're doing, here's why, here's where it's working, here's what's not working. You can use these more in-depth journey maps to go into, far more detail at specific areas so that people can sort of truly understand, where people are having a bad experience, why, and potential, sort of more granular areas that can be used to fix that. So we have a lot of information that can help sort of inform this and can help us understand, which bits where we can, again, interject and change things. If you recall, before we had those other factors coming in on the side. So isolated IT scientists, busy, focused on research, less on, the gory IT components, and so on. But this gives you, with this information, you now start to have some ideas and go, okay, if communication's not working and people are in different locations, how do we fix this? How can we start to, change the direction of those arrows or break that loop? So, these are just some ideas that might spring to mind in that sort of solutioning phase of the double diamond. Maybe we have town hall meetings to get everybody together and start talking about these things. If people aren't meeting often enough, maybe we can have collaborative projects to get, IT and the researchers specifically working on, things of interest to both parties. IT office hours, maybe the IT folks can come in and work more in the lab space on a regular basis, so it's not as hard to make connections. And again, people can learn what's going on. Again, relationship building, lunch and learns on various relevant topics. Again, just ideas that you can perhaps then look at based on that systems map before and go, okay, how can we change this? How can we break the cycles that we're in? So, these systems maps that we're talking about, they help us identify how to change. They give us places that we can interject. And so, just showing here on the system, some of the arrows are places you might start to solve and address the system and the environment that the organization has got itself into. So, the other nice thing as we look at building on this is the system gives you a model that you can then, both identify areas that you can intervene, change things. You can use it to think about potential solutions. You can also think about unintended consequences. That's often another side of things. We'll try something over here, but we don't, unless we understand the system that the one particular intervention operates in, you can have knock-on effects because everything's connected. So this helps at least give you some heads up for those types of things. And you can also, again, in the spirit of design, you can iterate, you can try things, you can see some small proof of concept activities. Let's try some lunch and learns, not too hard, but let's see how that's improving things. You can imagine, you might sort of get some surveys information out of that to see if that's helping to move the needle on communication or understanding or appreciation of, how IT and science in this instance can relate to each other. So all of these things, again, sort of can come together. So what I think, we've covered over the course of this is, here are the types of questions we're often faced with. Something always, people are always trying to change something for better or for worse. Now, I think with, some of the tools that we've talked about before and some new approaches, we have some different approaches to address that. So this is kind of the last couple of slides here. Again, I think design is something that we all do. There's a lot of information that we can leverage from the design literature. As you saw, there's lots of books and other things out there that can help us with that. And these design tools and processes, I think, are very relevant to the stuff we do. You can then combine that and create sort of maps of the systems that you're working with. And this, I've shown you a sort of sociological system here with people and processes and so on, which are, very similar to what goes on in many sort of biomedical research organizations. Same approach, applies to the infrastructure systems. Again, they're interrelated. Things have to work together effectively. There are different sort of approaches and techniques to sort of diagnose those. But once you combine all this together, it helps you identify, the opportunities to change. Where can I actually, push on this system to change things? And it may not be the obvious place. And that's quite often, when we've gone in and said, well, I tried this thing and I don't understand why it didn't work. It should have worked. And it's the system that is often pushing back. Both if you're a biologist, you may be familiar with homeostasis, how the biological system tends to keep things within a particular range. Organizations, institutions, processes, they have the same thing. And so, unless you look at the systems view, you can change all you want over here, but if the system itself isn't realigned, it'll ultimately end up back where it was before. And often that's not really where you want it to be. So the systems view gives you that perspective and at least sort of raises your eyes a bit to see what else might be at play, so that you can factor that in. So I think I've got a few useful links here. I think when we share this, you'll be able to get access to that. So I will click onto the last slide here. I'd say thank you. Really appreciate you spending some time with us today. Happy to take questions. Here's my contact information, website, newsletter, and everything else. So thanks again, and I hope you enjoyed it.